The best part about Section 5 is that this is something you're definitely going to deal with at some point in your life. So we're dealing with loans and investments. So loans, of course, you're going to get right after high school. For example, a college loan. Other loans you'll get is like a home loan, you might have a car loan, all kinds of different things. Credit cards, that's kind of a type of loan. So basically it's a borrowing of money, for the most part, or a product, I guess you could, with repayment containing interest. That's the most important thing. So what that means is, let's say you go to college and you take $60,000 worth of loans over your 4 years of college. So really you just kind of got like $60,000 for free in a way, and you haven't paid a dime on it. And then by the end of college, you have to repay it all back plus interest that accrued. So usually you're paying back sometimes, upwards of like over twice the amount. So you might pay $100,000 for something that was only worth $60,000 just because of the interest. With investments, now that's a good thing, right? Usually the deposit of money in order to make a certain interest rate, a return on it. So now the interest is a good thing, right? And things can be done differently. It could be compounded yearly, compounded monthly, compounded quarterly. We have to be very careful of how things are worded, and you'll see that as we go here. So let's just do some general interest. So it says, find the first month's interest on a $32,000 loan at an annual interest rate. So pay attention to the words. First month's interest at an annual interest rate. Okay, so let's think about this. I want to find 6.9% of that loan of $32,000. Well, to find the percent of something, remember you just take what it is and times the percent as a decimal. So in this case, I got to move my decimal 2 to the left. So it's really 0.069. So when we calculate that, we end up getting $2,208. Is that my answer though? Be careful. What did you calculate? You calculated the interest rate of $32,000 annually. So that's like once a year. So basically this is your interest for the whole year. We want to know the first month's interest rate. So just be careful on how things are worded because we still need to divide this guy by 12 to find just 1 month. And once I divide that by 12, I find out that the first month's interest is $184. Okay, so just be very careful on how things are worded. That's huge in this section. It's huge all the time, but very important here. Are recursive formulas for loans and investments. Let's kind of talk about what some of these things mean. It's very similar, okay, but we just have a couple things added onto it. So remember, we always start with the initial amount. And in this case, almost always we're going to have u sub 0 instead of u sub 1. We need 0. We need u sub 0 because we want to account that for no time has gone by. That's important, right? If I started at 1, that's kind of saying like a month has gone by or a year has gone by, depending on what we're using. So I'll always start with u sub 0 to say that's the initial time. Nothing has gone by. Now looking at each of these are the same. The only difference is one has a plus x and one has a minus x. And we'll talk about what's the difference between these two guys. So in the first equation, or in both of them I guess, u sub n equals, well, this is accounting for your interest. That right there. So really it's your rate on top of 1. And the reason why that is, like if I go back to this last example, if I wanted to add this on to that amount right away, I would take 32,000 times 1 plus 0.069. And that would add that on to that amount and find my new amount on that loan right away. So that's where that 1 comes from. So that R is just standing for our rate. So recognize that R is our rate, and just know that our rate is always written as a decimal. So make sure you change your percent to a decimal form. Okay, the next piece, you see how it has divided by n? What does that n stand for? Well, the n stands for how many times a year. And the key word to look for is compounded. So the reason why our last example didn't have anything divided by here, or even here, is that it was annually. So that's once a year. If I divide by 1, it doesn't change. So annually, we never really even need to put anything in there besides 1 because it doesn't change. So So be careful of that word compounded. So if it said it was compounded monthly, guess what your n would be? You'd plug in a 12 for n. Okay, so just be careful with that. And that's kind of one of the trickiest things about this whole section is being careful how it's compounded. And lastly, we have the plus x and the minus x. Well, we always talk about the previous term, right? The use of n minus 1. We always need it in there. Well, the plus x is if we're making a deposit. So, for example, I have an investment and I'm putting more money in my account. I might be saying like I'm putting in $50 each month. So that's where that plus comes from. If it's a minus, that means we're making a payment. So if I have a loan or a bill and I'm paying like, $100 a year, I subtract it because that's coming out of my account because I'm trying to pay something off instead. So really the same equation except one, we use a plus for deposits with our investments and we use a minus for our loans. So let's just get some practice at writing a recursive formula. We won't do anything with it, but let's just write one. So it says you invest $8,000 at 6% compounded quarterly. So keep that in mind, compounded quarterly. And you deposit $500 every 3 months. Well, think about this. If you compound it quarterly and you're depositing every 3 months, isn't that really quarterly as well? Because that would be what, 4 times a year? So just recognize that those match up. The compounded quarterly at the interest plus you're paying or you're adding $500 quarterly as well. So we always start with the initial amount, correct? And we said we're doing u sub 0 because no time has gone by. So 8,000. And then u sub n. Well, it's 1 plus the rates, which is 6% as a decimal, so 0.06. And it's compounded quarterly, so we just said that. It's 4 times a year. So we got to divide by 4 now. And then we'll take it times u sub n minus 1. And if you take a look, what needs to be added or subtracted to it? Well, we're depositing, we're adding $500 to it, so we have to say plus 500. And since we're already quarterly by our compound, by this 4, I can just leave it as 500. I don't need to like divide the 500 by 4. Okay, I can just leave it just like that because it's doing it every 3 months. It's doing it quarterly already. And then we always end with when or where n is greater than or equal to. In this case, it's going to be 1, right? Because it's always 1 bigger than what your initial is. Okay, so we got some practice, so now let's actually apply it here. So consider a $1,000 investment at an annual interest rate of 6.5% compounded quarterly. Find the balance after 30 years. Alright, so let's write our recursive formula. So u sub 0 equals, our initial was 1,000. U sub n equals 1 plus the rate, which was 6.5, so move 2 to the left, so 0.065, over quarterly again. So that's 4 times a year. So I got to put divided by 4 times u sub n minus 1. And then, are we making any payments or depositing here? No. So there's nothing, right? There's nothing being added or subtracted here. So we're not depositing any extra money into our investment. All right, and then I'm just going to write this. I probably don't need it in this case, but when n is greater than or equal to 1. Okay. So I want to find the balance after 30 years. Well, what I need to do is I could go through this over and over and over, or I could plug it into my calculator, which we're starting to get pretty good at, so let's go ahead and do that. So let's pop up your calculator, equation editor. All right. Oh, be careful right off the bat. Guess what? My n min, I'm saying my initial term is starting at the first term. No, we're starting at the 0th term, right? Because no time has gone by, so 0. Okay, and be careful of what this n stands for. We'll talk about that in a second. So u sub n, here's my recursive formula. So left parenthesis 1 plus 0.065 divided by 4, and my parenthesis times, remember you get your recursive u, and then for the sub, we got to use parentheses. And then the n is a little variable one, n minus 1. Now there's nothing after it. And then lastly, our initial amount was 1,000. Okay. And table set. Oh, not window, I want table set. Okay, this is what a lot of people think. They think that they should look at 30. And I'm just going to pop this up. So when n equals 30, does that really mean 30 years? So is this the amount after 30 years? So if you invest $1,000 for 30 years, you're only going to make about 600 bucks. That doesn't seem quite right. I should make more than that. Okay, well this 30 is not years. Remember, what did it originally say? It was compounded quarterly. Quarterly. So what does our n stand for? Right? 4 times a year, right? So really our n is representing like every 3 months. So when I put n is equal to 1, that's like 3 months. When I put n is equal to 2, that's like 6 months. When I say n is 4 in this case, that is a year. You see that? So really, if I would have done n equals 30, that was only approximately like 7.5 years. So I want 30 years. So what is my n going to have to be? Well, I'll have to take 30 times how often it's compounded, 120. So there we go. So it's at 120 like quarterly payments are of that interest. So that's what I need to do. I need to look at the 120th term. So let's go back in here. I could do my table. I like going to my main screen and doing that. So I'm going to call upon my recursive formula, and I want the 120th spot. There we go. That's better. So 6,919.37 cents. Okay, so be very careful with that. Remember, it's always based on how it is compounded, okay? So be careful.